We are. All right, welcome. It is Game 2005. We are Game Physics, right? I got to start by saying that I'm happy to be here for the fall semester. It's the first fall semester I've been here. I usually start in winter. So this is officially the first year. I'm Tom. That's who I am. I'm your professor for this semester. I've been doing this since 2011 for people who don't know me. I have a background in software engineering, and I share all kinds of videos on YouTube, like it says. Here's what I'm not. I'm not a mathematician. By the way, this does not say a magician for those people who can't read. I'm not that either, but I'm not a mathematician, okay? So if you think that you're going to get math from me, like true math, it's not going to happen. I'm not a physicist either. So when we talk about game physics, it's game physics. It's what's good enough, all right? That's what we're going to be talking about this semester. I am a game programmer and a software engineer, so that's where we're going to kind of apply the stuff that we're going to learn from the textbooks. And by the way, I'm not going to recommend buying any textbook for this course, all right, just as a get-go. If you do happen to have it or have access to it, I don't think it's going to be a negative. I just don't think it's required. And the reason why I'm saying that is because I'm going to try and translate everything from the textbook, and there's more than one when it comes to doing this properly, into a series of PowerPoints, and then during lab, which is going to be after this, I'm going to be, kind of doing some interactive sessions with some kind of platform where we can program, because this is a programming class as well. So not just math, but a little bit of programming. Is this a physics game engine kind of thing or a physics engine kind of class? Absolutely not. That is not now. I'm preparing you for what's going to happen later on, where there is an actual physics engine building kind of class altogether in another semester. That's not this program. So here what we're doing is we're just talking about the math to get you by, and let's go over a little bit of the outline of what we're going to be talking about this semester. All right, so I mean today, it's supposed to be today or week one. It says introduction and review, and it also talks about from the book chapters 1 to 5. That's insane. All right, I mean, I don't know if you've ever looked at the book. Anyone have the book at all or have access? Anybody? You have access? Holy crap, right? If you have access to the book, you notice that it's talking about number systems in the first couple chapters, how to write numbers, binary numbers, hexadecimal. We're going to talk about that a little bit today, but not very much. And then it goes into triangles and trigonometry. That's where I want to focus my time today more than anything else. There is a section on vectors, which you guys did all vectors last semester or the semester before, right? So I'm not going to focus too much on vectors today. And then this is funny, right? Next week, it's calculus, and you're supposed to learn calculus in a week. And I mean, that's really funny for me because I know it just takes way longer than a week to do that. So this is a nice schedule, but we're going to have to play with this a little bit. I was telling you in advance, please don't be mad, right? That this is the outline and I'm going to change the outline a little bit, but there's no other way we can do this and be successful in my opinion. And the reason why I'm saying that is because there's a lot of stuff to cover. And I want to make this a fun course, even though it's a math course. People are going to say, how can math be fun? I hate it. I just have to do it just to get by. I know, I get it, right? I was there. But we got to get through it together. I want to help you. That's why I'm here. I don't want to make it difficult. I don't want you to go, and what did he say? Right? What does that mean? By the way, people, I'm just going to put my hand up here, and maybe you guys can chime in. You can't see this on the recording, but who's good at math? Anybody? All right, so I'm getting a good kind of litmus test. Some people are not good at math, right? That's good. That's good. Here's the thing, right? People try, gamers, they come into a course like, the gaming course here at George Brown, and they're like, I love games, going to make games. I know you've heard this from me before for some of you, but I don't know how to program games, and I figure it's pretty easy to make games, right? Because, we use Unity, it's drag and drop, right? That kind of thing. Math, without math, really, you can't get any more advanced than what you've already done. It'll hamstring you in every way, especially when you do complex calculations, things to do with collisions for sure. If you're writing your own game engine in C++, you need to understand the physics and the math, especially trigonometry, which I'm going to be covering today, and calculus. If you don't have those two things, then it's going to be more difficult. Not impossible, but more difficult, right? So if you're not good at math, don't despair. When's the last time, who had calculus in high school? Anybody? Some people did and some people didn't. What about those people who didn't have math in high school? Like calculus I'm talking about. Or maybe it was so far back for some of us. I'm not pointing fingers at anybody, Terry, or anybody else, right? But I'm saying just maybe it's so far back, right, that you forgot, right? And it's possible because, you know, when I went back to university, I had forgotten calculus and trigonometry. If I talk to people about trigonometric identities, right, they'll be like, what is that? I don't even know what that is. That's another language. You're confusing me. Please, let's spend some time talking about something more interesting, right? So it's okay. If you don't remember it, we're going to go over it. And I'm going to go over it slow, okay? I'm not going to go over it fast. I don't want to try and fail you guys out. That's not why I'm here. I'm here to make it as easy as possible for me and for you. Okay, so calculus next week. Yeah, we'll do calculus next week, but I'm probably going to tell you that we're going to move into probably the week after as well. Okay, I'm just saying. And we're probably going to push some of this stuff down a little bit, especially when it comes to complex collision detection. I'm probably going to do more complex stuff in the second half of semester. Okay, so the first half of semester, we're going to focus on calculus and physics, even some of the physics stuff they've got here, like resolving collision resolution, in other words, what happens when you collide, not just detecting collision. I'm going to push that down as much as I can towards the second half of the semester. Why? Because even if I rush, guys, you're not going to get it anyway. Straight up. I'm just going to tell you how it is, right? It's hard. I want to break this out into a few modules. The first module is all going to be around review, calculus, some basic, trig and that kind of thing, and things like limits and derivatives and those kind of things. Probably will be the first test we do. Okay, so I'm going to break it out a little bit easier so you don't get killed, right? And then it's not going to be cumulative. So I'm not going to sit there and go, well, at the final exam that we're going to have, you need to remember all that crap. No. I'm going to kind of break it up so every test you're done, we're not going to talk about that again. It might be on there because you need to kind of know some of the stuff we've talked about, but it won't be something that that I'm going to try and kill you on. There are going to be a bunch of tests. The tests are going to be all some multiple choice, some true false. That's what's going to happen in this course. And there are going to be some short answer questions where you have to figure out the answer by hand, right? So can I do a full test that's online? No, I cannot do that for this semester because there needs to be some way of you writing stuff out, right? So that means that there's going to be a part of the test is going to be up on Blackboard, and part of the test, chances are, is going to be a written test where you're going to have to physically write it, and then you're going to have to hand it in to me, and then I have to review it, mark it, and put it up online, and then go over it with you. So that's kind of the format of what I'm going to be doing. If I can make it all online somehow, I will. Okay, I will do it. It's just really hard for me to figure out how you're going to do formula writing, right? Especially in the first half, the first part, like on your machine. I'm not quite sure how that's going to work properly with Blackboard. That's what I'm concerned about. So that's why we're going to be doing tests with probably paper in the first half. Not because I like it. I hate paper. For people who know me, I try not to do paper at all, ever, right? Because I think it's a waste. All right, so that's kind of the format of the test. There are going to be several assignments as well, right? Because the assignments are going to try and help you out to do the tests. Okay, so if I give you an assignment, the first one looks like it's supposed to be week 3. I'm probably going to give it to you next week, just as early as I can, right? So that way you can work on it. I will allow you to work in pairs, all right, and for the assignments. And there's a reason for this, right? There's a lot of you, and there's only one of me. That's one of the reasons. I want to make sure I can get the marking out to you as soon as possible, right? And the other thing is, there's a big movement these days around pair programming and learning, right? Now, there's a couple of approaches we could take here. One of them is, I could say, choose your own partners. That's one approach. And the other approach is, I choose your partners randomly. Like just, take the names, put them into a little program I write, and it'll just randomly issue the names through your group. And that would be bad, I think. But I want to get an idea of who would want to have picked their own partners. All right, so put your hands up if you want your own partners. You pick, right? And who wants me to pick? No one wants me to pick. All right, that's good. That's what I thought. And I wouldn't want that either, to be honest. I think that me picking your partners is, I don't know who they are. I might, group you randomly with somebody who slides right through, who doesn't like working. You should know who people, by now, the people who do work and the people who don't work. So pick someone who works. What about if you can't find a partner? Then the alternative is you're working alone, right? So we're going to get to that as we get to assignment number 1 and the logistics around that. There's going to be a bit of a fiasco, maybe a little bit of a sign-up sheet. You sign up with you and your partner and that kind of stuff. And then for the remainder of semester, you and that person are going to be paired for your assignments only, not for your tests, right? So all your assignments, assignment 1, I'm probably going to have, it says there's 4. I don't think that's a bad idea to have many little assignments, right? Because it'll make the tests less expensive in terms of what happens if you don't do so well, right? Even though it says a midterm exam here, it's going to be a test. Okay, please, I'm going to have more than one midterm test. Okay, and the reason for this is because, again, I want to break it up for you guys to make it as easy as possible, right? If I make a big midterm test, chances are what's going to happen is you guys are going to be killed, right? Because there's going to be a lot of information. It's not going to be an open book test. That's not this kind of course, right? It's going to be a closed book test. It means you have to know. However, I will supply or give you the option, I don't know which one yet, of writing your own cheat sheet, double-sided, right? And hear me out, because here's why I do this kind of stuff, okay? Now, it's a bad thing and a good thing. When a professor gives you a cheat sheet, that could be a bad thing, because that means I'm not going to give you any marks for the formulas, right? If you just know the formula, you get 0, right? Because you have the formula, right? It's about figuring out how to do the questions and getting the right answers. That's a negative, right? However, there are a lot of formulas for you to know, right? On the other hand, and I think it's worthwhile for you to have a cheat sheet that you make on your own. And I can recommend, when I say you make on your own, please don't use your cheat sheet. Don't make, I don't know, let's say, for example, Jamie's the master cheat sheet maker. And, she makes a really cool cheat sheet and then she passes it along to everybody else. Suddenly I get, Hercules cheat sheet and it's exactly Jamie's cheat sheet. It's got to be your own, right? It's part of the learning process, right? You making your cheat sheet and putting stuff on there. I'll tell you what to put on, by the way. I'm not going to say, I'll leave you to the dogs. I want you to fail. And if you make a crappy cheat sheet or if you don't bring one in, too bad. Worst case scenario, right? I'll have one that I can give you, all right? So we'll talk about that. I might provide one for you or at least give you some guidance. I'll say, here's this part, add to it, that kind of thing. Of course, everyone tries to text me and call me when I'm teaching. So that's how the tests are going to be structured. They're fairly straightforward. But again, it's all going to be around, I want to train you for the tests. So your assignments, you're going to get questions in your assignments to fill out. All right. The assignments will take you a few hours to do. It won't be like an hour and you're done. Okay. But then it'll give you practice, because math is all around practice, right? Math and physics. If you don't practice, it doesn't matter. You have to see enough questions so that if you see a question pattern, right, then when it comes to tests, you can be, you're okay with it, right? And that's what I want to try and do with the questions. Here's what I'm going to do. I'm going to tell you up front, right? If I give you practice questions or if I give you questions in your assignments, they're going to show up in another form on your exam, right? It's not going to be a trick. The numbers might change, right? But the exam will be almost identical to the assignments and the stuff we do in class, all right? There won't be a trick. I'm not going to try and trick you out or fail you out or try and test to see if you're a physicist or anything like that. That's not what my goal is here, is to try and get you to understand the material and be able to apply it from a programming perspective in any language, right? Now, how am I going to do this? Don't fall asleep yet. Okay, give me a second. All right, I swear, I don't want to bore you guys, right? Unity is one option. I'm going to put it out there. Now, I thought about a couple things. We could use Unity as a base, and that means you use C# in order for you to do the stuff that you need to do, right? And you can use a visual medium to, kind of show your results. So, for example, if I have something on an assignment where I say, make a Unity scene and show the ball bouncing, as an example, right? Might be some kind of assignment like that, right? I expect you not to use the built-in Unity physics, right? That's the point, right? That's one option. The other option, and I'm going to put it out there to you guys in a vote. I'm going to put up a little thing in a second to vote, is we do things from scratch with some kind of lower level technology, like, I don't know, JavaScript as an example, where there is nothing to help you, right? And then you learn how to program. Okay, now there's advantages and disadvantages to both approaches, right? The advantages on using Unity is you can get something out pretty quickly. It's rapid application development. You can kind of create something quickly. On the downside, it's not real programming. You're not really programming. It's scripting. If you think about it, unless you get really down deep and dirty into things like shaders and that kind of stuff with Unity, it's just drag and drop and a little bit of light scripting at the end of the day, right? On the plus side of doing something like JavaScript or C++ or something like that, then you're going to learn how to code, right? And you're going to learn how to apply it early before you get into your, how do I make a physics engine class later on in semesters to come. On the downside, it's a lot harder, right? So I'm going to put it up there. I won't put the vote up now. Before break, we'll put up a vote and see what everyone wants. I will go with what you tell me. If you say Unity, we'll do Unity. If you say something like a JavaScript or C++, we'll do that, right? So there is going to be a programming component to the course, right? And it'll be hitting you in your assignments. Will I ask you to program by hand randomly on a test with no test, with no computer, no IDE? I won't do that to you, right? So if I ask you programming questions, I might ask you something like, give you some pseudocode and say, what does this do? Or is this going to be fine for physics? Or will this collide? What's the collision going to look like? That kind of thing. But I won't burden you by writing code out by hand. It doesn't make any sense. Questions so far? Anybody? Yes.
So when you're saying that, you're either going to use C or C++?
One or the other, or something like maybe JavaScript, something that's simple. Well, it's Corey, to me, it's all around apples and apples, right? So if you do C++, then everyone's got to do C++, right? I can't let everyone do their own thing. Then my marking will be like crazy. Yeah.
So if you were using, say, JavaScript or C++, would we be allowed to use libraries?
Absolutely, right? But not physics libraries.
Yeah. But for JavaScript, there's processing, so that would be good for it.
For example, if you wanted to use something in JavaScript, let's say you want to use Phasor, for the actual environment, that's okay. I don't care. That's not the exercise, right? The exercise is, hey, can I make things by hand do stuff with physics? That kind of stuff. Not, use the built-in game engine that's built into, the system. What's the point, right? Otherwise, we're not programming anything, right? So, because both, I would say Unity as well as Unreal and anything else we decide to use in the future, and I'm going to put it up there as an option. It all has built-in physics engines, right? A lot of them, right? So we're going to talk about that. Any other questions before we continue? All right. So if you notice, so the first half is kind of basics, and then the second half, we're talking about things like angular motion and so on. I'm probably going to put some of this stuff up here because I'll tell you the collision detection stuff is the hardest stuff. It is. It's the hardest stuff to figure out. How to do even simple collision detection. There's many ways to do it. Even though he says it's going to be chapter 8, I'm just going to move these around a little bit. You're still going to get everything from this this selection of, in the outline. It's just going to be in a different order. And the reason for this is because it doesn't make any sense. That's why. You're going to get killed if you do it this way. You won't like it, right? And I want to make it more fun. So things like angular motion and friction, all that kind of stuff I'm going to bring up. And then you're probably going to get things like collisions, resolving collisions, and complex collisions, and all that stuff in the second half. Just letting you know. Okay, so what I'm going to do is I can't revise the outline. I don't have access to do that, but I will provide my own syllabus that I will share with you. And then eventually, hopefully, I can kind of, vie, kind of with Alex to kind of get this thing changed. I don't agree with it. That's all I'm saying. I just don't think it's going to be doable. I looked at it and I'm like, so the students are going to do this? It's insane, right? I don't know. I've talked to the previous professor as well, and he said it was insane and he couldn't get it done, right? So it wasn't just me, it's too difficult. And that's why I want to try and make it more like the big elephant that we chop into pieces so that we can eat the elephant, right? As opposed to choking. I don't want to choke. I don't know if that's a great example, but it is what it is. So is there any questions around the outline or what we're doing? I know, please look at this outline again. If you look at the book on the right-hand side, I'm going to recommend other books to read from as well. And if I recommend another book, I'll show you where you can get the resources for free most of the time. Safari Books Online has this stuff. You can also find it on your own. There's some legal ways of getting it, downloads. I'm not going to talk about the illegal ways, right? Yeah.
Are you going to make like a live document, like your version of this outline?
Yes, that's going to be my syllabus. I'm going to share that with you guys up on Blackboard, right? So that way there's no surprises, you know, that kind of thing. You're not going to look at it and go, so what's coming next? What do you mean there's an assignment due, right? No. For the most part, though, the assignments will be pretty much where they are right now. So targeting week 3, that looks good. And for assignment number 2, targeting week 6 before midterm, that makes sense, right? And then right after midterm, assignment 3 and so on. The positioning of this stuff looks good. It's just the content doesn't look good to me, right? So that's what I'm going to be changing up. Now it says 5 assignments for 10% each. I'm more prone to do 4 assignments, you know, and if you look at the tests in terms of how much it's going to be, your midterm is 25 and your final is 25. I don't want to make them bigger than that, all right? Which means I want to kind of give more beef to assignments and smaller tests, maybe a test in between the other tests for each of the modules, right? Again, just to make it easier, not to make your life hell, right? And if I do a midterm test, like a second midterm or something like that, it's not going to take up the entire time, right? So we're together for 2 hours, as an example here, doing this lecture. And then in lab, we have a lab tonight, and we have a lab on, 2 labs on Thursday. That's where the test will be. So that means maximum you're going to get is an hour and a half or something like that, which means I can't give you that many questions, right? I'm not going to kill you with too much test. On that, one of the other things that I have to do is when I was arranging for this course, 3 o'clock start doesn't work for me, right, in general, right? So I was talking to the administration, and they're saying we can push it down by half an hour. I'm sorry, but it's just that most times I won't be able to make it by 3. So this course, starting next week, will start at 3:30, right? I apologize for that. But so everything's going to be shifted. I know, Corey, I apologize. I'm disappointing you already. But it's 3:30 to 5:30 for this section, right? This stuff starting next week. I won't do it to this week, and then 5:30 to 7:30 for each of the labs, right? So NADA knows about it. The administrator knows about it. So it's not something that they can do in the system because the system won't allow it to happen. But we're going to do that. So it's going to be 3:30 to 5:30 starting next week, and then 7:30 after. Any questions or concerns about that? Yeah.
So there's no change to the lab you have on Thursday at like noon?
There's no new lab. There's only 2 labs. On Thursdays, I have 1 lab at 3:30.
Okay, that's the one.
Yeah. It's going to go from 3 to 3:30 though, right? Okay. Yeah.
Where's the class right now? How's that going to work?
I don't know. But they told me that everything was going to be okay, right? So
My class goes from 5 to 8.
worst case scenario, like I want to tell you, I want to put it out there for you guys, right? I'll do my best to come as early as possible, but it's like I said, I have a conflict, so I can't make it here before 3:30. I could be 5 minutes late. I'll try my best to be here between 3 and 3:30, but I don't want to promise you. That's why I'm saying let's just move it back to 3:30 and then everyone's good. I can't do anything about it, and it was something that was kind of in place before I even, like some other commitments that I had before they asked me to do this. So I want to help everybody out, but there's only so much I can do. I can't promise you that something I can't do, right? So 3:30 it is. And if you have a problem with it, please go to your administration. I mean, they know about it, right? There's nothing I can do to change that. Yeah.
Like I'm looking at my schedule right now, and this class goes from 3 o'clock to 5.
So it'll be 3:30 to 5:30.
And then there's no implementation of a lab.
There is a lab. There's 3 labs. 1 today from 5:30 or 5 in this case to 7. It'll move to 5:30 to 7:30. It's going to be all shifted a half an hour. And on Thursday, there are 2 labs. So there's 1 lab per section. There's 3 sections, right? The first lab on Thursday is 3 o'clock. It'll be moved to 3:30 starting next week, not this week, right? And the second lab on Thursday starts at normally 5. It'll go to 5:30 to 7:30 next week. Okay, so you should know your labs and all that stuff. That's what the timetable changes are going to be. Any other people have any conflicts? If there's a conflict, please come see me during the break. We'll figure something out. Worst case scenario. Here's the good news, though. On the last lab, so it won't be this lab today, and it won't be on the first lab on Thursday. I will record the lab on Thursday evening. That'll be the last lab. I would have gone through it 3 times at that point. So even if you can't make it to that lab, if I have an exercise, I won't make it due that day by midnight. I'll make it due the next day or something like that. And there's going to always be some kind of exercise or something that's going to be due, a little bit of homework, that kind of stuff. That will take the place of things like quizzes and other stuff like that that'll be in here, and it'll count towards your assignment mark. Again, I will share all that with you next week. Okay, so that's the changes. Any other questions or concerns? All right. Got to give you the good with the bad. What can I tell you? All right. The other thing that I want to do is I want to share some tools with you. There are going to be some graphs that I'm going to ask you to do. And there is a web tool I recommend. If you go to Desmos, have you guys heard of Desmos? Anybody? It's actually a really cool graphing tool. It's free. And what you can do is you can put any formula in here you want, and it can help you graph stuff out. You will be required to use this during one of your assignments. So please, or graph it out yourself. You can graph it by hand, or you can use a program. I recommend something like this. I'm telling you in advance so you know that you know where it is, right? So for example, if I put something like x squared, and I can use the caret, right, to go x squared, you can see that I'm going to get an instant graph, right? Which is cool. That means I can get a graph for a line or a curve immediately, right online, and there's nothing to do. There's nothing to install. So please use Desmos going forward, right, for any kind of stuff you want to test out. Especially anything like if you want to look at things like cosine. So if I go cosine of x, right, you can see the cosine curve right away. We're going to be talking about this, how it works and all that kind of stuff. What happens when I do things like, 2 cos x, right? It's a scale. It's a scalar that I'm using, right? And if I add something to the end, like plus 5, you can see that it translates it up or down if I put a minus, right, where it is right here. So you can see what this is, kind of a neat little program. You can also export from it if you want to check it out. So please fool around with it, because I will be asking you to make some, maybe 1 or 2 graphs, just for an understanding perspective, right? And that's sine. Let's cosine. Let's look at sine. There's sine. What's the difference? Anyone remember what the difference between sine and cosine is in terms of how it works? Yes.
In sine, the center point is not at the highest scale.
Is it the center point or is it the starting point?
Starting point is not at the highest scale.
Okay. So if you notice, that's very good. So you notice what we're talking about here is right here, right? This is the starting point of sine and cosine. We're talking about trig today anyway. Might as well talk about this with you. So your sine and cosine, it starts like this, and it comes up, and it goes back down, and then over to here. That's your full sine wave right here, right? Okay, anyone have an idea of, without me doing anything like that, what is the frequency of this wave in radians? I got to test you guys out. What? Who said 2 pi? Oh, okay. No more questions for you. 2 pi. So what's 2 pi? If we think about what 2 pi is, what else is 2 pi? Anyone know? 360.
And also it's the circumference of the circle.
Circumference of a circle. I like this. So some people know something about trigonometry. That's a good thing. It would be bad if no one answered me. That would be bad. I've had that before in the past during math courses. So yeah, it's a circle, right? So if you think about this, right, if this is 0, and if you look at the graph, it just tells you pi over 2 is here, right? So that's 90 degrees, right? And then as we go down to here, that's 180, that's pi, right? And that's 3 pi over 2, right? So that's 270, and here's 360. So that's the whole rotation. So if I say, right, if I give you an angle, sine of 90, right? Let's do it the other way around. 90 must be pi over 2, right? Because of this graph. That's why I'm showing you the graph here. And it's a really good way to understand, so you can quickly get those angles in your head, right? If I say a sine of 90 degrees, then what is the answer of sine of 90? Looking at this graph. 1, right? If you look at the where it is, it's right there. It's 2, 1. That's the vector, right? And the same thing goes with the sine of 180. It's 0, right? And so on. So you can see how it oscillates. Whereas in cosine, and I want to bring this up because we're going to talk about trig in a second, right? So we're going to talk about triangles and all that. You can see that the 0 point starts off at here, right? It's not at the origin anymore. That's the beginning, right? And then 90 degrees, the sine of 90 is 1, right? Or is it 0? Sorry, 0. And then as we keep going, a sine of 180 is -1, and so on, right? So that's why this is a great visualization tool for me. When I was learning about trigonometry, you know, back in the day, I didn't have something like this. They drew it out, right? And I couldn't figure it out. I was like, what does this all mean? So where did they get in this? How did the professor or the teacher come up with, you know, the answer right away? Well, because they had this in their mind. So if you could learn anything this semester about trigonometry, think about these sine waves here. And let me just make it bigger. And again, I'm going to use a scalar for that. It's just going to put 2 in front of there, right? You can see that if we multiply it by 2, then the answer is just going to be multiplied by 2, right? Because that's a scalar, right? All right, so really, at the end of the day, we talk cosine and sine. What about tangent? What do you think the graph is going to look like for tangent? Anybody? Don't look at Desmos. Okay, let's just do it together because you guys are cheating if you do it that way, right? What would it look like? It's kind of a weird graph, yeah.
At a regular interval, it'll go way off to the bottom and you can get the top.
Let's see what it looks like, right? It looks like one of these. This is what tan looks like, right? So tangent, and you might say, why are we learning this, Tom? Right? Well, because a lot of times we want aliens to kind of, you know, go through a certain path. If I get a group of aliens attacking my player, and I want to, you know, give them a certain, call it a path function, right? I can map that path out right here, man, right? What it's going to look like. So if I give them a tangent path, and if they look like they're going to, some part of their path is a tangent, that's the path they're going to follow, right? Now it's going to be in intervals, like you said. So if you look at tangent's kind of funky, right? So if I do a tan of 0, then it's 0, right? And if I look at a tan, something else that's going to map, it doesn't map the exact same way because what's tangent anyway? Sine over cosine. And we're going to talk about the trigonometric identities, how they all work in a bit. But I want you in your mind, whenever we talk about something, and if you're confused, you're like, I can't picture that, right? The motion that he's talking about. Try and graph it out. And this little editor here will give you the kind of a 1-2 on how to do that. Any kind of function you can put in here. Remember that it's y equals to whatever this is, right? That's how it works out. So whatever you put in on the right side is going to come out in a graph as a function of x. Y is a function of x. How about functions? Anyone not do functions in school for some reason? That would be like really crazy if somehow you got into the program without doing functions. So we're not going to talk functions in this class, right? And like I said, I'm not going to talk vectors too much. We'll have to do it later on as we approach collisions. We have to. We have no choice. And there's different ways of resolving collisions in this class, right? We can do that with vectors. We can do that with calculus or integrals as well. There's lots of ways to do that. There's going to be also one part that I want you to program. I want you to program a collision between 2 points. I'm going to get you to program a collision between a point and a line. I'm going to get you to program a collision. You guys should know this stuff offhand, and some of you already do, right? And that's fantastic. If you already know those things, how to program collisions, all the power to you, right? It's part of what we're going to do here. We're going to try and level the playing ground with everybody so everyone knows how to do those things, right? So don't despair. Hopefully you're not going to be bored when it comes to that. But those are the simple collision things that we're going to be talking about. So stuff like, how do I do a collision between a circle and a line? How do I do a collision between, you know, a complex object, an irregular object, and something else? How do I do those things? How do I calculate those things? There's many ways of doing that. How about a bullet? And what's the complexities around bullet physics? How does that work? How can that mess us up, right? We're going to be talking about those things as we get to collisions. All right, so I give you a tool let's get to the PowerPoint a little bit. So again, in this class, I'm really going to be lecturing. There's not going to be an opportunity for me to actually show you stuff. This class isn't equipped for you to have any kind of laptop or anything like that. Does anyone not have a laptop? That's a good question, right? Because some people may not have one. And so you see there's people that don't have that. So even if I ask you to do an interactive exercise with me here in the class, in the lecture part, you can't, right? And it's not fair for me to try and do a test in this class with you here unless I physically hand you something. So that's a problem. All right, so let's go over this. So when we talk geometry, right? I'm not just talking about geometry in 2 dimensions in this class, right? And I want to start off by saying that anything we can apply in 2 dimensions, we can extend to the 3rd dimension. It just makes it more complex. So let's look at an example that we can do in Blender. When we talk geometry, right? Guys and girls, I can't make it so boring that you're going to watch me read PowerPoint slides, okay? I'm not going to do that, all right? So if you think that's the way I lecture, not going to happen. So if we look at something like Blender, right? And we have a 3-dimensional shape. Doesn't matter whether it's 3-dimensional or 2-dimensional. You have geometry for your models, right? Your models, most of the time when we do polygonal modeling, we use meshes and shapes. And the one thing I always want you to remember when it comes to polygonal modeling and geometry in general, when it comes to moving things around, is that every shape has at least 3 things, right? What are the 3 things that all 2D and 3D shapes have? All of them. Anybody? Yes. Okay, so edges, that's the new word, yeah? What else? Vertices, yeah, vertices. What's the other one? Faces. Oh my God, thank you. All right. I know this sounds simple, but people forget for whatever reason that that's what it is. The other thing is that most of the time when we do 3D stuff, we break the object into triangles, right? And this is where it comes down to you need to know your trig. If you don't know your trig, then it doesn't matter how good you are at modeling or anything like that. One day down the line is going to catch you and you're not going to know what to do. A lot of the stuff also that we do with lighting in 3D, we use vectors for sure, as well as trigonometry, right? So you need to understand this kind of stuff. So even if we have a 3-dimensional shape here, you still have, in many ways, the same kind of, we deal with the same things here in 2D as well as 3D. Right now, my camera is just a perspective camera. But if I go into orthographic mode, right, then I'm going to still see a 2-dimensional shape. It's going to appear to me as a 2-dimensional shape, and we're going to forget or ignore the 3rd dimension. But at the end of the day, we're going to still have these shapes. So shapes in 3D, shapes in 2D, shapes in 3D actually are extrapolations of shapes in 2D. In the real world, of course, they're much more complex. What we're really going to be focusing on, though, is triangles. Okay, so triangles is kind of the base of what we do here when we program for games. In fact, when we make a mesh, even complex meshes, what we want to do is we want to cut it up into a series of triangles, and we want to make them as simple as possible, because the more triangles we have in a model, the more computationally expensive it is to use in a game, and that's bad, right? So we're going to show you how to do that later on. Have you guys taken any modeling courses yet? Okay. Is it happening this semester or is it next semester? Do you know? Right? You will be getting something like a Maya or a Blender or something like that at some point, just from an understanding perspective. It's not because we're not going to do that here, although there might be some kind of translations, rotations, scaling, all that kind of stuff that I might use a visual aid like Blender to show you. I don't expect you to know it. Okay, so when it comes to things around triangles, we use trigonometry. So geometry is basically the study of shapes. Trigonometry is really the study of certain shapes, special shapes, triangles. Please forgive me for those people who are bored out of their mind and who know what trigonometry is. But I got to kind of hit the holes, right, in all of your knowledge. And I'm doing this for a reason, because I want to make sure that everyone's on the same page. What's an angle? It's a way of measuring direction. I'm not going to read the whole thing. And it's easier if we have some kind of way of measuring angles. There's different ways of doing that. One way is when we use, I'm just going to bring this down a little bit. We can use degrees, and the other way is we use radians, right? So which one does the computer use? Does it use degrees or radians? Who knows? By default? Radians, right? And that's kind of non-intuitive for us, right? So when we're programming a physics, any kind of physics interaction, any kind of change in direction or anything like that, we need to use radians, right? And if you want to use degrees instead, you've got to convert from degrees into radians, and this PowerPoint will show you how to do that. Okay? But the idea that we have a radius, what is a radius? It's the center point, to the edge of a circle where it meets it kind of creates the circumference of a circle. If I take a center point and I have a rope and I have some kind of drawing instrument and I draw around a center point, I can create a circle by just having a radius, right? Again, it's the center to the perimeter or the circumference of the circle. Okay, that's really what a radius is. We're going to be using, again, all the stuff I'm going to be talking about today really briefly is the stuff that we're going to be building on over the entire course. So you might think that this is okay, but once I pass some of the trigonometric functions, you're going to go, damn, I really should have listened, because we're going to be using those when it comes to physics all the time. For example, you're going to get a physics problem, and it's going to say, okay, you've got this shape. I want you to get the tension in newtons, right? As an example. How do I do that? I need to use Pythagorean theorem, and it's the stuff that we're going to be talking about today. So please don't discard this kind of stuff or ignore it. It's going to be going slow, but it's going to ramp quickly. All right, so please bear with me. All right, so again, think about a circle. We break it up into a bunch of parts, components, if you will, and we use either radians or degrees. You can convert from radians to degrees with a certain way of doing that, with dividing by 180 degrees, multiplying by pi, dividing by 180. If you want to go from degrees to radians, if you're going to go the other way, from radians to degrees, which is going to show later on, you're going to multiply 180 and divide by pi. Pretty simple. So it's a very simple calculation. It's way easier than converting from Celsius to Fahrenheit, that's for sure. When you look at this as an example, here's some common angles, 60 degrees, 90 degrees. I'll tell you right now, most of the games you make, when it comes to firing arc, all that kind of stuff, or direction, if you're going to change in direction, if you're going to have a game, whether it's 2D or 3D, that moves smoothly in different directions, you're going to have to use Pythagorean theorem most of the time, or Euclidean distance, right? And so it's a good understanding of how do I switch direction? How do I move from, going, straight forward? What does forward mean? What does the direction mean? When I change my my direction, I change my angle of attack. Or maybe, for example, if I have some kind of player and I'm going to attack an enemy, but I only have a firing arc with my my front guns of 30 degrees. How do you figure that out, right? You need to understand how to angle your guns or whatever it's going to be for your player. And part of this is understanding how angles work. I'll tell you the most common angles we use is 30, 60, 90 all the time in games physics, right? We try not to go into 37.5 or something crazy like that. Yeah? The numbers are easy. Remember what I talked about? The first thing I said here, we're going to do what's good enough. I'm not a mathematician. I'm not a physicist, right? So we're going to do what's good enough for games. That's what I want you to get through from this course, right? So chances are, if I give you an assignment, right, I'm going to have numbers that I've already pre-worked out to a certain amount, some kind of point, right? And if I give it to you on a test, what's going to change? Not the question type. Maybe the wording might change a little bit, but the numbers will change. That's all it's going to change. So if you know how to do the numbers and plug in everything, and if you've seen that kind of question, you can recognize that question type, then you're going to be okay on a test. If you haven't done your homework or you didn't do well on your assignment, then you're going to suffer on your test because you haven't done your pre-work. Okay, so again, one of the nicest angles, and we're going to use this for everything from when we talk about normals in 3D, right, or perpendicular or right angle, 90 degrees is the special angle that we need for almost anything we do in physics. all right? Especially when it comes to things like calculating the distance between two pixels. I want to find the distance between two pixels. Remember what pixels are? Pixels are just a series of squares, tiny little squares on your screen. That's what they are, and they have color. They have color, and they have position. But that's what they are. They're still squares. So I'm trying to calculate the distance from one square to another square, and I'm probably going to use Pythagorean theorem. Now, let me ask you a question. I kind of talked to some of you before. Is using square root a good thing in GAME? Do we use square root? Should we use square root when it comes to calculation? No one knows. The answer is no. Hell no. We want to avoid square root or complex calculations like that, right? Because it really chomps at our computational rate, right? Especially when it comes to things like calculating the distance between 2 points. So there's other ways to do that. And the other thing we don't want to do is we don't want to divide when it comes to programming as well. We want to try and multiply as much as possible. All right. When we talk about the circles, we have circles divided into 4 quadrants, right? Notice on the top right, it's all positive, X and Y. This is great from our Cartesian geometry perspective, but more often than not, we're not using Cartesian geometry in when it comes to game programming. What are we using? Where is the 0, 0 point on the screen? Yes. Where? Top left, right? And usually it goes from top left to bottom right. Now, there are some systems that go from bottom left up, just like Cartesian geometry does. But for the most part, it's top left to bottom right. So even though we're showing Y is positive here, on a game screen, it would be flipped, right? Y would be actually negative going up and positive going down. That's going to be a bit of an obstacle for us when it comes to programming we learn here in class in some kind of programming language, right? Because we're going to have to reverse that a lot of times. All right, different kinds of angles. By the way, I'm going to take a break in 2 minutes because I know you guys are fading. I'm fading, right? Different kinds of angles. So we have acute angles, we have obtuse angles, and we have a reflex angle, and that's where the angle's greater than half the circle. Chances are you're not going to see as much reflex angle stuff as you will obtuse and acute angles. It's just from a naming convention perspective. It's not because I'm going to make you use it or remember it or put it up on a true-false multiple choice question. That's not really a great question for me. All right, so once you have the radius, you can figure out the area. And of course, this is one of the equations you're going to need to know, the area of a circle, which is pi r squared. What is pi? It's a special number. It gives you some of the digits here, 3.14159276, I believe, and so on. And it'll keep going. And it's it's repeating and non-terminating, right, forever and ever. The other thing we like to look at is circumference of a circle. And you're saying, why am I telling you this stuff? Because when it comes to angular momentum, we're going to be talking about area, and when it comes or circumference, it's going to come up again later on when we're going to be doing things with circles. Anything to do with with straightforward forces, particle physics. When I take an angry bird, and I pull on the angry bird, it gives him a little bit of force. He's going to be flying through the air, and he's going to have an arc, a parabolic arc, as he lands somewhere, right? And that's straight particle physics. We're going to treat the angry bird like a particle, right? But what about complex physics, like things like torque and all that kind of stuff that we're going to handle near, the second half of the course? You need to understand a little bit more about angles and a little bit of trigonometry. So that's why we're using this as a way of reviewing. Okay, so again, we talked about circle being 2 pi radians, which is about 6 and a bit of radians. That's what it is, 6 point something, right? And mathematicians like to talk about the unit circle. I'm not going to really talk too much about it. I will talk about unit vectors later on. I will talk about the normal, right, which is of unit length. A lot of times we want to get the normal, which is a perpendicular angle to a certain particular line or shape. A lot of times we want to look at the normals when it comes to lighting, any kind of lighting and shading and all that kind of stuff. We use normals for that. You're going to hear me use the word normal, and all that means is something that's perpendicular either to a face or an edge for the most part. Okay, why do we need to convert? Because a lot of times it's not just us using computers. Sometimes you want to make it so that the player It shows degrees for the player, but the computer and the computer functions need radians. So we need to do that. And here's the conversion. I'm not going to go over it with you. I already said it earlier, which is if I want to get radians, I take my degrees, multiply it by pi, and divide it by 180, and that's your, the formula. Am I going to expect you to remember that? Hell no. I'll put it on a cheat sheet for you even. So any kind of formula, things that you think you might need to remember that we're going to work together. Either you're going to make your own cheat sheet, either we'll make it together as a class, or I'll give you one. One of those. There's nothing to worry about there. All right, I think 4 o'clock. I still got a few slides to go, and I'm just going to be talking about triangles in lab today. When we get to our lab session later on today, we're going to actually use some, maybe either Unity or something else to program with, so I can show you how to calculate the angle and all that kind of stuff, especially when you don't have enough information. How do I calculate the angle or a triangle when I don't have enough info? There's one lab tonight, right, from 5 to 7, and there's 2 labs on Thursday, right? One that goes from right now from 3 to 5. It'll be moving to 3:30 to 5:30, and then another one that goes from 5 to 7, which next week will be moving to 5:30 to 7:30. That's on Thursday, right? Sorry? Is it 5 to 8?
Yeah.
2 hours.
It's 3 hours a second.
Is it? All right. Well, you know more than I do because I know it's supposed to be 2 hours, right? Total of 8 hours, right? This class 2, next 2, and the other 2. So there's only 2 hours. All right. So let's take a 5-minute break, please. I know people are dying. Get your coffee, come back. Let's break it up a little bit. I know this is not the most exciting material. And when we come back, we'll continue with triangles.